Hi, this is Fazana again. Uh, Welcome to part 3 of this topic. I hope you've watched parts 1 and 2 before watching this video. The questions become progressively higher level through the 3 videos, thereby raising your level part by part. Let's look at the questions. Diagram represents a large cone of height 6 centimeters. Okay, let's just make that a bit more obvious. 6 centimeters. Oh, that one. Okay, that one. All right. And base diameter 18. The large cone is made by placing a small cone A of height 2 centimeters and base 6 centimeters on top of frustum B. Okay, calculate the volume of frustum B. So I hope you've watched my videos on volume and surface area where we covered frustrums, but let's just look at it. Okay, so you can tell we want to find the area of this particular frustrum. So we're going to take the volume of the big cone, take away the volume of the small cone. Yeah, so volume big minus volume small. Okay, yeah, as easy as that, and you get given left with the volume of the frustrum. Okay, so the volume of the big one, big, equals, and you should know the formula for the volume of by heart. Yes. So the volume is 1/3 pi r squared, so the area of the base, times the height. All right, so let's stick the numbers in. So you've got 1/3 pi, the radius of the big one is 9. Yeah, and while we're at it, we might as well do the radius of that, which is 3. Okay, yeah, and while we're doing scale factors, we'll just do scale factor of the length is 9 divided by 3, which is 3. Okay, but in this particular question, they're not asking you, but we want to check it right at the end. Okay, so you've got 1/3 pi and then radius squared, so you're going times 9 squared times the height, which is 6. I don't actually put it on my calculator yet, because I'm going to do the volume of the small one, and then I will go on my calculator, because I'm all prepared, and it'll be that minus that. Yeah, all right. So here we've got 1/3 pi times 3 squared times the height of 2. Okay, and that will give you 508.94, and that will give you 18.85. And when you take that away from that, you get left with 490.09 centimeter cubed, yeah, being the volume of the frustrum. Okay, all right. Now, because we're doing this topic of scale factor, length, area, volume, let's just check something. If the volume of the small is 18.85, centimeter cubed, then you can tell the scale factor of your volume will be 3 cubed, which is 27. Yeah. If you want to find the volume of the big, yeah, you can tell it'll be 18.85 times 27, and voila, when you go put it on your calculator, you get the 508.94. Okay, yeah, so that's a really good check, isn't it? Especially if it's like a 5-mark question. All right, okay. Next question, we're ready for you. Ooh, I think. All right. PQRS and PLMN are similar quadrilaterals. Okay, and then they give you all the lengths. All right, work out the length of MN. Okay, cool. Okay, so we know we've got to look for two corresponding sides. So can you tell that's 12, but then of the bigger one, it would be the 12 plus 8, so that's 20 centimeters. So your scale factor of your length is 20 divided by 12, which is 5/3. Okay, and I'll just leave it like that for the moment. All right, so A, your length of MN would be, we're going from bigger to smaller, so you can tell we're going 13.5 divided by 5/3, which is the same as 13.5 times 3/5. Yeah, and you can cross divide. That's 1, that's 2.7, and 2.7 times 3 is 8.1 centimeters. All right, yeah, okay. Question B, work out the length of LQ. So that's that bit there. Okay, now again, prepare in advance, because you know where, with all these scale factor things, we're going to actually be calculating that whole length. So over here, I'm just going to put -9, because what I am going to be calculating is that whole thing there. Okay, so now that length of the smaller one is 9. So then I'm going 9 times 5/3, and yay, I can cross divide. So 3 times 5 is 15. Yeah, so LQ. Okay, so you've got 15 minus 9 equals 6 centimeters. All right, yeah. Okay, so no matter how odd the shape is, everything just sort of falls into place. Okay, the area of PLMN is a centimeter squared, whereas the area of the whole thing, PQRS, is KA centimeter squared. Okay, so the area of the whole thing is KA centimeter squared. Yeah. Okay. All right, well, that looks like a scale factor. Yeah, so if the scale factor of the length was 5/3, then the scale factor of the area would be 5/3 squared, which would be 25/9. So if we wanted to find the area of the big one, wouldn't we be going A times 25/9, which would be KA centimeter squared? So you can tell that the K must be 25/9, because that's what we would be multiplying the area of the small one to get the area of the big one. Yeah, all right, that was easy, wasn't it? Okay, the area of the shaded region, so again, it's the big minus the small. Yeah, big minus small is 105.6. Okay, all right, so then the area of the big one is 25/9A. Yeah, I'm sorry, the question is work out the value of A. Okay, so 25/9A minus the area of the small is A equals 105.6. Okay, now when you look at that A, you can tell that's like 9/9. Yeah, because it's like 1A. Yeah, putting it with the same denominator. So 25 minus 9 is 16A/9. Yeah, or 16/9 A is equal to 105.6. We're using the Faz format of 6 divided by 2 equals 3. We can cross multiply. So 16a equals 105.6 times 9, yeah, which gives you 950.4, which is your 16a. And then if you divide by 16, you've got a equals 59.4. All right, okay, that was looked intense, but you can tell as long as you play around with the diagram, write things as much as you can. What I do find is, especially with non-calculator, you have to leave that as an improper fraction. Then it's easier to work out, because if you'd actually written 1.6 recurring and then tried to do it here, yeah, it would have been really quite confusing. Yes, so leave it in improper form as much as you can. All right. Okay. Next question. David made a prototype container box A. He now needs to make the proper container box B that's mathematically similar. Box A, surface area 7, box B, 175 centimeters squared. So we can immediately find the scale factor of the area, which is 175 divided by 7, which is the lovely number 25. So the scale factor of the length would be the square root of 25, which is 5. Yeah, right. David used 5 kilograms of cardboard to make box A, which is the small one. Yeah, and again, if he's using 5 kilograms, then you know we're talking about volume. All right, so we have to find the scale factor of the volume, which would be 5 cubed, which would be 125. Okay, so if you used 5 kilograms to make box A, then the amount of cardboard you'd need to make box B would be 5. So will be 5 times 5 cubed, which is the scale factor of the volume, and that would give you 625 kilograms. Okay, cardboard is sold in 10 kilogram packs. So if they're sold in 10 kilogram packs, then the number of packs that you will need equals 625 divided by 10, which gives you 62.5. How many will he need to buy? We know we're going to have to round up, so he will need 63 packs. All right, yeah, good. Great. Okay, next question. Mark has made a clay model. He will now make a clay statue that's mathematically similar. The model has a base area of 6, and statue's base area is that. So again, let's do the scale factor of the area, which is 253.5 divided by 6, and you get 42.25. Okay, so that's what's been a dot. Okay, so scale factor of the length will be the square root of 42.25, which is a nice friendly one of 6.5. Okay, Mark used 2 kilograms of clay. So again, we know that's volume. So let's go find our scale factor of our volume. Will be 6.5 cubed. Okay, and again, everything sold in 10 kilogram bags. So the volume for a statue will be 2 times 6.5 cubed, which gives you 549.25. And the number of bags we'll need will be 549.25 divided by 10 will give you 54.925. And again, we know we've got to round up because we've got to buy a whole number of bags. All right, yeah, good. Okay, last question. LMN is a right angle triangle, okay? Angle MLM is 90 degrees, okay? PQ is parallel to LM, okay, just in case we need a parallel thing. And again, because it says it's parallel, you can tell it's mathematically similar, yeah? Because you have all your F's there, so you're going to have corresponding angles, so that angle will be the same as that angle will be the same as that angle, yeah, all right, and they share a shared angle there, all right, okay. The area of triangle PNQ is 8, okay, and the area of LPQ is 16. Work out the area of triangle LQM. So we want that bit there. Okay? Shade it ourselves. All right. Okay, so you can tell that is similar to that. Yeah? All right. So if the area of that is 8, I'm just going to make up some numbers, nice friendly numbers. So if I make that up, because when I look at that 8 and the 16, they have 4 in common, yeah? So let's put 4 there. So we know that's going to be 4, because we know the area would be half base times height, yeah? So it would be double of the 8. And here it would be 4 times 8, because 4 times 8 is 32, and we half it, we get 16, okay? So can you tell we've got 4 there? And then the height of the big triangle would be the 4 and the 8, which would be 12. Okay? So can you tell the scale factor of your length would be the 12 divided by the 4, which is 3. Okay? Yeah? All right. So the scale factor of the area would be 3 squared. Okay? We don't need the volume here. All right, okay, so now we want to find the area of that. So what we're going to do is we're going to say the area of LMN, the bigger one, will be the area of the small one, which is 8, times the scale factor of the area, which is 3 squared, and that gives you 72 centimeters squared. Okay? So now you can tell the area of LQM will just be the area of LMN minus the area of those two. So area P and Q plus area LPQ. Yeah, so we've got 72 minus area of P and Q is 8, and then the area of LPQ is 16, so that comes to 24. So 72 minus 24 is 48 centimeters squared. Okay, yeah, simple as that. I said it looks, questions can look really confusing, but once you understand that it's a scale factor question, then all you're doing is your scale factor area, scale factor length, trying to find an area, you're multiplying it by the scale factor of the area, and then that bit of it is really quite basic, yeah, because it's always the area of the bigger minus the area of the rest of it, and you get the shaded bit. Okay, yeah, so it's combining everything together. All right, that's all for now. I hope you enjoyed working through all these questions together. It's like having a study partner. We make a good team, yeah? Keep working hard. If you think you're working hard, work harder than that. And read this again in a few weeks. Okay? And just keep working harder. All right. Remember, you're in control. Until next time, take care. Bye.